Good day. Welcome to NX University. My name is Craig.robillard, and topic for today is, where is my data? The agenda we'll go through today is we'll do a little exploring in the before computers era. How did we archive our engineering data in the before times? And then some of the digital age challenges. We'll look then at two scenarios: managing NX data in the native operating system, and then we'll look at the managed data environment using Team Center. Not so many years ago, and in some places presently, we have corporate libraries. So using the old analogy, you can see the old drafting board references. Many have never worked on drafting boards, but for those that have, there was always a routine to, once your design was complete, to turn it over, and you can see the archive storage. And if you look in the lower right corner, you will see the hanging files. Should a copy need to be made, the grayish in the lower left is a Blu-ray machine. When a engineering vellum copy was made, it was done on a chemically coated paper. The background would turn blue, the lines would be white, and hence the term blueprint. Advantage of this process, you could always tell the copy from the original. In the engineering sections, engineers need reference data, often copies and blueprints of the drawings, but there might be engineering specification, vendor parts, engineering calculations, and so on. Now, a special case, note in the upper right corner. These 3-ring binders document all engineering changes for a specific design. Think of a airframe, a plane. You basically describe, this is the condition, these were the parts, this is the as-built, these were the changes made, and if you take a negative scenario, something went wrong, the plane crashed, you have all your documentation to go back through. Recent news line, the Hubble. It's not like you can go stop by and measure things. Trying to figure out what was going on with the Hubble required a process much like you see here, where you can trace your engineering data all through from beginning to end and figure out how a system is working, or troubleshoot, or fix a problem. Lastly, documentation of engineering, ideas, patenting. Some companies will protect their patents until product disclosure. The risk, if someone invents the same thing you did while you're developing your project. The formalized engineering notebooks tend to be bound composition books, sketch-based. Notice the signatures at the bottom. These can document and record the time and date of when an invention was created. Now, fast forward the conversion to digital. Today, very few have seen drafting boards or worked on them, but you may have to turn over your data in a printed format. However, when we look at the valuable digital data, Aberdeen, which is a company that surveys and consults in the data management field, ran some productivity surveys, and they found some interesting things. 72% of data is stored on file server, but interestingly, no formal process was ventured as being in place. So when you start to see on local desktops and no data management, these are copies, these are variations, these could be out of date. So an interesting paradigm starts to surface, especially with remote working. Where's my data? Now, some companies have put in multiple product data management and product lifecycle managements. They tend to be point solutions, mechanical, electrical, and these start the process. The challenge comes in is how do you share data between disciplines? Also a degree of when an update is required, how do you keep them all in sync? The leaders in the field, approximately 34%, have a single integrated managed data environment, and they see many benefits from this. When we look from a different perspective, when an organized data management strategy is not implemented, the hidden factory surfaces. A hidden factory is a term out of Six Sigma quality. It is work that has to be done to accomplish a task but is often undocumented. Now pick, for example, on a factory floor. If you had to take parts off, deburr them, then put them back in line. That's a hidden factory, but it's very visible on a manufacturing line. And it wouldn't take long for corrective action to be put in place. So the deburring step was accomplished before the parts were delivered. Now in engineering, hidden factories tend to be very prevalent. Why? We can't see them. And one of the topics when you go to look for data from the Aberdeen survey and others, that an average person, you can start to see when they go to look for data, can spend up to a day a week. From a management perspective, imagine if your whole engineering staff could gain a day a week in productivity. This is why we tend to look for how do you find and fix a hidden factory, and this is where data management starts to play. Now, when we're looking for our data, one piece of the puzzle isn't always enough. We tend to focus on the drawing. However, there could be more to what we need to find, such as a simple question, I want to change this material, what would it affect? And that's the question, what happens when a change is required? We tend to need a more comprehensive view. Managers will ask for data to be put in context so they can make decisions. And if we only have a drawing to look at, we seldom change just the drawing. There's usually a ripple effect. We have to update the assembly, for example. And if it's a revision, okay, the assembly BOM stays the same, but what if it's a new part? Now the bill of materials updates, and so on. So today's topic is broken into two parts. We'll look at the native operating system, NX, and we'll use the Windows folders. Then we'll break into a series of folders, which are returned as search folders. Now, Team Center is analogous to having one giant folder or having your own private internet. So we'll look at these two scenarios for the same product in the two different contexts. Now, a little background about an NX assembly. The assembly file is actually tiny. It does not copy component parts into a big assembly, making it bigger and bigger. What it instead does is what file, in what folder, or in what location do I load relative to the absolute coordinate system. This is referred to as the transformation matrix. So assuming that you have a simple assembly, part 1 would be brought in at absolute 0, 0, 0. Then the subsequent parts would be found and then placed on top of that part. When we construct our assembly, what we're really doing is adding pointers. So this file, this location, at this physical location inside the assembly file. Now we can control how we load our assemblies in native NX. On the left side of the screen, you will see you have the assembly load options toggle, or when you're opening files, if you look, you'll have an options button. And the panel for the assembly load option is on the right. It's red from top to bottom. In this case, we're going to load from a folder all components, and what is referred to as a partial load is on by default. It loads the visualization and the minimum amount of data to load your assembly quickly. And then if you need more information, NX will load more information depending on what command you've selected. So to keep a context, we're going to look at a motorcycle. It is 800 parts. All the components are in one folder, and you'll see there's 800 items. So we are choosing to load from a folder, all components, and I've brought up the fully load, and the video will show you in just a moment. You'll see about how long it takes to load an 800 part assembly, all data. It's fairly quick. So here's our outcome. 800 parts. Notice we have a top level assembly. We've named our folder what the top level assembly is. Imagine if it was 1, 2, 3, 4, 5, 6 and no title. How would you know what the top level assembly is? Here it has meaningful. We've also broken our example assembly into sub-assemblies. That's what the little plus signs are for. So if one were to look at the side stand assembly, could plus, open it up, find all the parts inside. So this, you will see the top level assembly is really a structured bill of materials. In this example, they're names and could very easily be part numbers. Now, it's not typical to have one engineer handle 800 parts. So let's break our assembly into logical groupings and start assigning the front and rear wheel assemblies to different engineers, the rear seat, and we remove our parts from the top level assembly and then put them in these sub-assembly folders. Now we've partitioned our design. We still have a top level integrator. We now have 3 other people working on sub-assemblies. However, when we go to open our file, notice the pointer is going to look to the rear seat assembly. So this is why it's in the light gray. It has found the pointer, but it cannot find the parts to load. Why? We moved the parts from the single folder to multiple folders. And we see the according warning on our load. We can't find this file using the current search operations. So let's fix that. On the right hand side of the screen at the top, you'll see we've changed to look from search folders. Now I kept this example simple, where they're all on one laptop, they're all in one place, and we've given the search folder panel the 3 areas to look in, as well as the top level assembly. And this time, the entire assembly loads without incident. Now here's the challenge. While this example is very simple, imagine your own work spread apart across multiple people, maybe in multiple buildings, some working remote, and where would your bearings be? Where would your fasteners be? Very easily done in a folder and doing it in a hierarchy, so you only have to put in one folder. However, how would you organize yourself? How would you keep it maintained? What would happen if you added more bearings? How do we ensure they don't land in the top level folder and not in the intended one? So these are hidden factories behind the use of share folders. Now continuing, part versions. we'll focus on the as saved. If we were working in a group and I have opened my swing arm, someone else has opened up the rear wheel assembly, and they've included my swing arm with their file open. Now I have the swing arm opened. Until I save it, they will have a different version of it. This could go on all day, this could go on all night, but the point here is the versions, depending on the environment, and in this case, share folders, have to be synced to conditions. So the as saved, NX will tell you if you're out of date or not, then there's a newer save, but requires a certain degree of manual intervention. And lastly, load scope. This is an 800 part assembly. Some could consider that fairly small, others could consider it very large, but imagine doing an entire automobile or a 1,000,000 part assembly, like a ship. There's no way your memory in your machine could ever load the entire assembly all in memory. And here we show on the right side the structure only. What we're illustrating, this is the same top level assembly. These are all the pointers to the files. Then we can check an empty box and load just that subassembly. If we wish to do the interfacing to the front end, we could easily go into the frame, just turn on just the frame component, and make ourselves a very quick interface file, and then work in context. So NX has quite a bit of flexibility in the native operating mode, and it trades with our ability to manage our files, our file structures, our folders, all within a certain context. In small groups, this is very manageable. The larger the group, the more interesting the challenge gets. Partial loading is on by default, and NX will load additional objects as needed. If it needs them, it will ask. You can see the move component frame illustrated here. You might have a alignment constraint relative to a part that's not loaded, so NX will ask you. You can also have sketch parameters, say a tab and a slot, tab on one part, slot on the other. This would be examples of interpart data while you're working your ideas out. So let's watch this in action. Here we'll open from one folder. We'll go to our options, one folder, as we're going to fully load in this case to give you an idea how quickly the system can work, and we'll leave the rest defaults as they are. Now, I'm going to switch to the single folder example. Notice I've titled the folder what the top level assembly is. You've got a lot of scrolling to do. We've chosen to alphabetize. Yes, you can use folders in a hierarchy underneath, put the top level at the very top, and then all the components in a subfolder. That works just as well. People can be very ingenious. So here is our 800 part assembly loaded from one folder. So let's close that, and let's look at the next case. Here we'll go to the search folder example where we're going to distribute our work to different people. Now there's a default, so we can just take that out. and then we'll add in our appropriate folders. Now in this case, I'm going to forget to add in the front wheel, and rear seat assembly. So let's see what happens when we go to load the top assembly again. This time, all the parts are not in one folder. We've separated them. As expected, we get warnings. We cannot find files using our current search options. This ever happened to you? Has somebody ever moved a share folder or moved their parts around on you? In most larger organizations, this happens frequently. Easy enough to correct. But in my case, I know where my new folders are. Sometimes you have to go and ask. So here, we'll go back to our search folders option and we'll add in the missing folders. Now you'll notice this is a bit of a tedious process because you have to search from the beginning through your hierarchy, and you can't add them all at once. They must be done one at a time. Next, and where most of these videos would be, like, speed this up, I wanted to give you an idea. Imagine if you had a few dozen of these to do for every user. Yes, you can automate this, but this is what the manual process starts to look like. And of course, you'll never miss one, will you? So now we've added in our 3. Now let's start from the same parent, this time with the subfolders added. If you look at the bottom of the screen, you'll see the loading bar. So this time we get a successful load. Some components are loaded from the top level folder. Some are loaded from the subfolder. Okay, we'll take our next look at Team Center. Team Center is ideally suited where in a share folder mode, it's very difficult to organize, sort your data other than within the folder. So if the manager were to ask how many of these parts are purchased, how many parts of these are make, how many of these parts are existing, you can see we've talked so far about just data. Data is something. It starts to become more meaningful when we start sorting into which parts are purchased, which parts are made. If we're challenging, can we reuse this in our present context, that's starting to now put data into context, and we're explaining our intent with a story. This part goes into this assembly and it's going to be used in these products. So Team Center is a global product. It is effectively one interface with a lot of applications. It's analogous to a handheld phone. You have a common operating system, you add apps to it. That way you tailor it to what your needs are. In Team Center mode, you have a similar functionality, only these are more CAD and documentation based, but it's on top of a database. So that means we can find where things are used and what folder are they referenced into so we can move things around. and we can view CAD data without needing the CAD applications. So as your groups get larger, the number of projects start getting bigger, and you're managing your data, Team Center becomes a logical next extension. Now, Team Center folders are unique. Earlier, I mentioned that an item in Team Center is like a web page. Folders in Team Center are like bookmark folders. They collect data, web pages, together into logical groupings. They look like Windows folders, but they function like bookmark folders. So if an item changes, if a part changes, if a part updates, so it does in your Team Center folder. If a copy of a part changed in your Windows folder and you have a copy of it, it stays that way. So it's possible in a Windows folder environment to be out of date or designed to the wrong reference. So Team Center is a product targeted at the management of design and documentation, and then you can organize yourself using folders. So we saw earlier in the paper archives, this is the digital equivalent, where we can have our hanging part folders, we can have our engineering documentation, we can have a number of other items all grouped together for a project. So some of the terminology, I've already alluded to it. Call it a part number, but Team Center refers to everything as an item. So you have an item ID, 1, 2, 3. It's unique to the database. 4, 5, 6. It's unique to the database. You can name the item ID, so 1, 2, 3 bolt and 4, 5, 6 bolt are allowed because they have a unique item ID. But for humans, we might want a little bit more. So bolt and then add in the part description tag. Bolt M10, bolt M12, M12 by 1.75, and so on. Now we start getting a better feel for, I have this item ID, this part number, this name with this description. And then folders, as we've briefly discussed, collect related objects together, and they are very powerful because you may have an item ID belong to multiple Team Center folders. They're not copies. Much like a website bookmark, if the item ID updates, so do all your pointers inside your Team Center folders. So this can exhibit some very functionally interesting behaviors. Now, how do we find data? Many do not memorize their part numbers. Others do, but we'll keep this context to searches in part name and description. We have 2 wildcards. The question is a replace substitute for a single character. So imagine a name, optic, or optical, or optics. You could do OPTIC question mark. And now look for that last variable would cover optics, optical, and so on. The splat, for lack of a better description, replaces multiple characters, so it is a wildcard. We can place them in the string. However, where we place them, because Team Center searches from left to right in order of precedence, we can get different answers. So let's show you an example. This example comes from a university. They do large optical devices. So their assemblies are approximately 1 million parts. So optical mounts and mounting of mirrors is something that's commonly done. And the system is reconfigured on a regular basis. So looking for existing data is a common practice. Now this is looking in the part name field, and if you look in the 6 mount example, you will see the 009416, that's the item ID. The dash is a separator, and then the part name field is showing. You can also display the name and description, but I'm limiting the context on this one. So we've searched for this, we're looking for the 6-inch mirror mount. So wildcard 6 wildcard mount finds it for us on the left side. Let's reverse the order. Let's look for mount wildcard 6. And you will see in the lower right corner, see the mount lens 101.6, there's your mount 6. Modal base mount 6, you can see the field appears. So, but you get very, very different results. The point of this cell, pay attention to how you name your files. Is it bracket? Is it BRKT? Is it BKT? Largely a matter of how do you find things. Not a problem if you don't do this. This is where the wildcard and the searching comes into play. Now, here's the advantage of working on a database. While we have a CAD file, it's done in our CAD context. This could easily be a vendor spec sheet. This could easily be another form of engineering data. If it is used in an assembly, we're reading across the top line. This is the Where Am I Used under the Impact Analysis tab. And we see the clip ring is used in 2 different frame assemblies. So if we focus on the 001287 revision A, frame 1-frame assembly. At the bottom of the screen, where am I referenced? Here we take that same clip, and we can find that frame assembly we're referencing has all the components in one folder. And if we wish to go right to the frame assembly, we can search for the 001287 or copy and paste the link to the folder into our home space. But the idea here is by organizing your data into context, you can also share it. It's about the equivalent of handing your notebook over. Now we can take this and extrapolate it. Folders can be used for more than just engineering data, but let's walk around this cell. In the upper left, you can see a project management folder. All projects typically follow a project management for the planning and organization. You'll have design reviews as you go through a project typically. There's all the engineering data, mechanical, electrical software, and then there'll be manufacturing and quality assurance. Missing on this cell, project closure. Now, if we expand our project management, you can see where we have folders, and these are typically descriptions of documentation-based information. So budget, any engineering theory of operations, project requirements, or along the way, what's your schedule? How are you doing relative to schedule? In many organizations, these are all managed off on shared drives and in separate locations. This example is illustrating that it can be done in one locale. So think of the dynamics of, I wish to reuse an existing motorcycle assembly, but I want to convert it to an electric drive, and that's the context you're seeing here. By being able to copy all this information in a few moves into another reference, we've created an electric motorcycle conversion project, which reuses the existing Buell motorcycle design, and then we just convert over the drive area. And that's what we start to see at the top in the design reviews. What are the requirements? Mechanical, electrical, service. And in our engineering area. So we have not only the CAD designs, but we have the power conversions and other of the engineering calculations. And we'll show you this in the video next. But this just gives you a little idea. In the center at the bottom, you will notice we have references to battery pack design. Motorcycles, you've seen them when they go to take off. Like a dragster, you would see a squat. In the back end squats, there's ways to calculate that into the frame geometry. Rake and trial is how stable is the device at speed. So it's a way to integrate our engineering calculations into our actual designs. This summary folder panel gives you an idea what is possible. So let's take a look at Teamcenter. This is the rich client. This is the home space. And if you'll see the look familiar, it is patterned after Windows File Explorer. What are you looking for on the left? More data about it in the middle, and then a preview panel on the right. Now, if we just make things in Teamcenter, it goes into our new stuff folder. These are basically where do the web pages appear. And patterned after the Windows file folder, we can go through each individual item. You'll see the visualization. Notice we're not using CAD at this point. But we can quickly go through and search for data and what is it. So you don't have to be a CAD engineer to use CAD data. Now here's an example of our parent. Now this is a web page link. Now these can be brought in, but watch your security. For an illustration and example, it works well. It could very easily be a specifications document. And notice we can put in the link in multiple places. So it can be a standalone or it can be referenced into the, call it the file folder. Now this is the active workspace version of Teamcenter. It's web-based. And here we're going through the same data. And the point here is, be it active workspace or rich client, depending on your function in the organization, one will serve you better. So here, I'm asking to take inside of NX, I can search, I have a Teamcenter link, active workspace, and I'm asking to open it up. No share folders, go find it. Remember, Teamcenter is essentially a giant share folder. And if you look along the left column, and if you look for what looks like the green globe out to the left of where the cursor was just picking, that's the active workspace link. Now, let's cover topics typically not addressed. But this is in the Did You Know? So here we find that there's a lot of data available. These could be Word docs, these could be Excel sheets. And I'm leaving the warnings up just as a reminder. Make sure your security is set for this. This is a link to a calculator. It lets us open from here. And then when the application opens, so here's my original. I can very easily save it as my specific version and put this Excel sheet inside this item revision. 001456 along with the parent web page. So these topics are basically illustrating that you can do much more than just CAD data with Teamcenter. This is a similar example, rake and trial. Again, this is a web page. It is a calculator. It also goes through on how to instrument and set these up for verification. But some of these calculators include the math. So as you can see, we've taken our engineering design guides, we've put them in along with our engineering data. And now let's look at a different class. We want to take our parent, and we've created an Excel spreadsheet, put it in the item revision. And so you can see it all. Let's shrink it down a little bit. But this is an Excel sheet managed in Teamcenter. And we can go through and run our calculations. Now earlier we meant data in context. I want to make a change. What happens if I want greater range? How much bigger of a battery would I need? I want to go from a single-seater to a two-seater. What rider weight? And here you get just a quick idea of how much energy is required per 100 miles for various vehicles. Now notice we have references in multiple places. That's okay. Teamcenter allows us to do this. Now let's go back to NX. And here, instead of going from Teamcenter to NX, this is NX into Teamcenter. Notice the folders make things easier to find, quicker. You can search for them, or you can go through and make it easier for you to find them in the next trip. So now we've taken our parent motorcycle, we've done a save as. It has a new item ID, new designations, and we'll start to say, can we reuse some of our engineering calculations as part of the context of this project? So instead of the Sportster engine, here's the electric motor. We'll make this one a belt drive, and you can see this is a work in process, so haven't attached the drive pulley yet. Instead of a engine, here's our battery box, and we can dig in deeper and deeper to the battery modules, to the battery cells. And notice we can use our design guides and bring them into this folder structure as well. So our engineers are off and running. Let's look at the program manager. So instead of trying to do this in disjointed areas, the program manager starts to organize. And one of the things we're starting with is this is the existing design. This is a simple copy and paste the reference. So the entire project for our donor bike is in one step. And one of our buddies is doing a new concept. So let's look at this in Structure Manager, which is normally used to read BOMs. But we can open up the visualization panel. And this is examining CAD data without having to use CAD. So here's a new concept. No PDF drawings available. It's somebody's idea, but we would like to take a look at it. Pick the part, the bomb expands. We can turn it off. And here we have a center steer hydraulic based concept. But in terms of which new project would you launch, one based off an existing frame or one that would require a lot more investigation in new frame dynamics, either way it's recorded as an alternative concept. Now that we've chosen just to modify from a donor bike, we can work our way through and say, well, what existing tools and fixtures are available? If we had them available, the earlier design reviews for the original Buell would be nice to go over. Here we're going through our present manufacturing, which fixtures, which service procedures, which service tools do we have, so we can check our interfaces, taking a more global view. Now, this being an electric bike, sensors, schematics, electrical distribution. So here we're bringing together multiple groups. Now, we had the rake and trowel calculator. In this case, we've turned it into an engineering sketch. And we're starting our first iterations. So we also have prior experimental data that tallies that in the front wheel, the rake and trowel calculation is known, gives known performance parameters relative to a center of gravity. So as we start creating our device and we calculate the center of gravity illustrated here, we're fairly close to the parent. It means our handling dynamics should be similar. This is the original. Notice it's a Harley Sportster engine. Eric Buell was a Harley engineer who wanted to expand Harley's offerings. Buell went out of business in the late 90s when Harley decided to stick to its parent offerings. So it makes a nice test example for this illustration. And then lastly, we'll see we can track all of our engineering changes, summarize them. So now, whether our groups are distributed, working around the globe, or anywhere else, where's my data? It's a lot simpler to answer with Teamcenter. Thank you. This concludes our presentation.